This is the last day of our acquaintance. I will meet you later in somebody's office. I'll talk, but you won't listen to me. I know what your answer will be. I know you don't love me anymore. You used to hold my hand when the plane took off. Two years ago, there just seemed so much more. And I don't know what happened to our love. Days and days of friendship has been stale, and we will meet later to finalize the details. 2 years ago, the seed was planted, and since then you have taken me for granted. But this is the last day of our acquaintance. I'll meet you later in somebody's office. I'll talk, but you won't listen to me. I know your answer already. This is the last day of our acquaintance. Oh, oh, oh. I will meet you later in somebody's office. Oh, oh, oh. I'll talk, but you won't listen to me. Oh, oh, oh. I know your answer already. Oh, oh, oh. I know your answer already. Oh, oh, oh. I know your answer already.
All right, so we'll just go ahead and start. So this is the exercise from a few years ago, 2018 it looks like. And it's a data processing with respect to Pokemon. And if I get anything wrong, I apologize because I don't know anything about the game. But basically, each Pokemon has a type of attack and defense. For example, ice, grass, or fire. And when an attack of type A is made against a defense type B, the results can have a force multiplier, either 0% for not effective at all, 50%, half as effective, 100%, which is normal, and then 200%, which is super effective. So for example, if an ice Pokemon attacks a fire Pokemon, it's half as good as before because, of course, well, I don't know. I don't see why that would make sense because water would put out fire, right? I don't know. Anyway, a rock fights a fairy. It's just normal. I don't know. Whatever else there is. But anyway, you can see it in this kind of this grid here, right? So normal Pokemon fights a normal Pokemon. There's no actually the white here is normal. But if it fights a ghost, then it's no effect, zero effect at all. Didn't I have that in there? Right. So no effect or zero effect? 0% not effective at all. 50%, 100%, or 200%. And those are just numbers, right? Likewise, what we've got is a list of Pokemon in a Pokédex, or whatever it's called, identified by their number, their name, and their type. So Bulbasaur here is a grass type. Ghastly is a ghost type, etc., etc. So the idea here is that we want to write a program that if I gave you the name of two Pokemon, Jinx and Flareon, right, then we should produce something that looks like this. Jinx, which is ice, attacks Flareon, which is fire, and does half damage. Okay? So we've given you some starter code here. That link is no longer working. But here's the starter code for the Java version that I gave. I didn't give anything because I figured that you could go ahead and start from scratch on this one in 2018. But here is the type file. It's a DAT file, and so it's separated by spaces. And here is the Pokemon file, which is a CSV file. So the first thing I want to do is I want to read in those files. So let's read in the type file, or actually let's go with the Pokemon first. Pokemon file, .csv file, right? ... All right, so help me out here. I mean, there's one way that I could do this, is I could use the NIO library and just read in all lines at the same time. Do we remember how to do that off the top of my head? Because I don't. No? Okay. So then let's go the traditional route using a scanner. S is equal to new, and let me call it something else. I'll call it the Pokemon scanner, right? Or just scan is equal to new scanner. And we're going to have to create a new file here. That file is just stored simply in the current work, or actually the data directory, data/, and it was called Pokemon.csv. Right? Yeah, go ahead.
I've got it right here. It's files.readAllLines, and it returns a list of strings.
All lines, but then you have to do a path, so a new path of data Pokemon.csv, and let's go ahead and import that, yay. Import the path. Cannot initialize file path. Why not? It's NIO path. Files cannot okay, why? What was the example that you're looking at?
It just says paths.get. Right?
Paths.
Yeah.
.get. That? Something like that?
No, there's no new.
Oh, okay, because it's probably a static.
Yeah.
And then I need to import paths instead. There we go, and that's going to throw an IO exception. So yeah, I'll surround that with a try catch. And when you're forced to surround something with a try catch, you just rethrow it. So throw a new runtime exception, catch and release basically, of E. There we go. And so I need to create that. Let's do it as a list, I think, of strings, right? And call it lines. And then here I'll say lines is equal to that. So I'm going to need the list here as well. There we go. All right. Now I'm going to process each line, right? So process each line, ... Now remember what the Pokemon line looks like. And for what I'll do here is I'll put a split screen here so that we can look at it at the side. Right? So each line is going to be their ID, which is kind of irrelevant, their name, and then their type. Right? So if I had 3 pieces of data, that's telling me that maybe you want to create a Pokemon class, which we've already done, right? And hold all 3 of those pieces of data. And you can do that. But ultimately, all I want is the name and their type. So what's another data structure that could get us there a little bit quicker? A map. So let's create a map of a string to a string of a Pokemon to type. Okay? New hash map. Okay? And I'm going to have to import all that stuff as well. Import, import. And you could go up there and just go import java.util.star, right? But that's kind of bad practice. You don't want to, this is called a wildcard. Just import everything in that package. Well, now what if you have a name conflict, right? So be more intentional. Only import that which you need, okay? All right, now for each line, for string line in lines, an enhanced for loop there. I'm going to split that string out into its 3 components. So line.split, and I'm going to split it along commas. Okay? That gives me tokens, which is going to be represented by an array of strings. Now we're only interested in the 2nd token and the 3rd token. So let's go ahead and put into Pokemon2Type their name, right? Dot put, tokens sub 1, and I'll map that to tokens sub 2. Okay. Now, if we want to, we can c.out.println Pokemon to type. Just as a really quick sanity check here, we're going to have to print this out. It takes as command line arguments. Let's see. Let me just steal these over here, Jinx and Flareon, because we already have some expected output there that I can compare it to. Jinx and Flareon, apply that, and run it. There we go. So I'm only, it's not complete yet. I'm only debugging this. Mewtwo goes to Psychic. Does anybody know anything about Pokemon that can verify this? Oh, okay. So then let's look up, just do a spot check here. Arbok, they are indeed poisonous. Right? I'm convinced that they're all there. Let's go ahead and get rid of that now. So I've got a Pokemon name to type. If you want to be more explicit, you can call it name. But then I'd have to change it in 3 places. Or you can right-click it, refactor, rename, Pokemon name to type. And it's done for you everywhere. Okay? All right, now I've got the 2 Pokemon. Now I can get their types. But also, before I do that, let's go ahead and read in this file over here. Once again, I'm going to go ahead and split screen this. Come on, I want over there. There we go. And just so that we remember what it looks like. And I'll go ahead and get rid of this for now. Ultimately, if I'm going to hand this in, I, of course, would delete all this cruft, right, before I hand it in. But how are we going to process this file now? We've got electric fights psychic, and then we've got this number here. I do need all 3 of those things. But that really doesn't seem like an object to me, right? Because it's 2 strings that together have a meaning, and then it maps to another thing. Ideas? Think about Hawk 12. What did you do? A pair, right? Pair or tuple, right? And there are Java tuples. There's a library to do it, but it's terrible. So let's just go with the pair class that I provided. In fact, I copied and pasted that over here. Okay. So what do we? The pair of a string to a string is going to map to a double. Right? So that's the kind of map we need. The map is going to map a pair of strings to a double. Right? And I'll call that what? Pair to multiplier, right, is equal to new hash map. Once again, you can elide that away so that you don't have to repeat it all. Right? Let's process that line now, or process that file now. I'm going to steal, actually I can reuse that variable lines there, right? And instead of opening up Pokemon CSV, it'll be Pokemon types dot dat. Right, dat, there we go. And then I will have a for loop here. Let me move this map declaration down here just to be consistent with everything, right? Now for each line, I'm not going to split it based on a comma. I'm going to split it based on a space, right? And then the pair to multiplier here is going to be a pair.make tokens. The first token is going to be at 0. The second token is going to be at 1. And then that will map to the final token, tokens of 2. But remember that that's going to be a double. So how do I convert that string into a double? Dot parse double into tokens sub 2. Too many. There we go. And is that good? Yep, there we go. Now, if you wanted to make your life easier, of course, you could do this on multiple lines, right? If you wanted to make the code more readable, a pair of string to string, I don't know, I'll just call it the pair, is equal to pair.make, and then I can put that right here instead of having this very long line, right? And then what I could do is I could put this into a multiplier variable, so double multiplier is equal to that, right? That's a little bit more readable, right? And it's also allows you to break it up into a step-by-step process. Once again, let's go ahead and spot check this to make sure that it's working. I'm going to go ahead and print out that multiplier map. Let's run that again. So rock to normal is 1. We can go ahead and check it out over here. Where is rock? Does anybody see rock? Where is it? But okay, there we go. Rock to normal is going to be white, so it's 1. That looks good to me. Let's look at something that's not 1. Just okay, electric to grass should be 0.5. Where's electric? Okay, there we go. To grass, 1/2. Right. So I'm convinced that that one works too. Let's go ahead and get rid of that. Okay. At this point, from our command line arguments, we've got Pokemon name 1. args sub 0, and we've got Pokemon name 2, args sub 1. Right? Remember that in Java, the arguments start at 0 because the executable file name, the class is already part of the class, and it's not included in the argument list. I put these into variables so that I can reason about them instead of always just having sub 0 and sub 1 all over the place. But now what I need to do is I need to find their type. Right? So string Pokemon type 1 is going to be from that map. There we go. Pokemon to name of Pokemon name 1. And then type 2 is going to be, oh, sorry, what? Oh, what did I do? Oh, not named it. Oh, dot get, thank you. Dot get and dot get. There we go. I've been doing a lot of Python lately. And in Python, lists are actually, actually no, not lists, but dictionaries. There we go. That's what they call them in Python. Dictionaries, you can have strings as the keys. Right? Right. And I've got type 1 and type 2. Okay. Now that I've got their type, find the multiplier. Right? So I'll create a pair here, pair of strings to string, and call it P is equal to pair to multiply, or actually no, I need to make the pair out of the types, right? So pair.make, Pokemon type 1, Pokemon type 2, and then I can get the multiplier. Double multiplier is equal to pair to multiplier dot get P. Right? Now I've got all the information I need to output a single simple line that looks something like this. Okay. So of course I don't have any error handling here. What if they gave me a non-existent Pokemon name or something like that? We wouldn't have done that though. Okay. So yeah, you can go ahead and write some error codes to make sure that everything was found, but system.
You could have just had a check.
Up above, you could check you'd have to make a check here. Is it a valid Pokemon? Is it a valid Pokemon? And is it two valid types, right? So I don't care that much, right? %S, and let's go ahead and go with F instead. Attacks %S, and does %F, and only to 2 decimal places of accuracy there for that one. And that's going to be Pokemon name 1, Pokemon name 2, and then the types. I guess type goes next for 1, and then type for 2, and then finally the multiplier. There. Oh, thank you. So that it looks nice and pretty. There we go. So, and then get rid of my debugging stuff up above. Ultimately, remove it and remove all of this cruft, Jinx, Ice, attacks Flaren, Fire, and does 5x, or half damage. Okay. All right. There we go. That's it. Only 15 minutes to do that, but that's because I was set up and I knew what to do. What I want to do with the remainder of time is not do the C version, because if you're interested in the C version, watch this afternoon's live stream or the main sections, because I will do this exercise in the main section, but for C. And there, of course, C is a, not a rundown language, but a Spartan language. That's how we should put it, right? It's a Spartan language that doesn't have these nice data types, this pair, tuples, and this map, and all of this other stuff, right? So it's going to require us making a structure and then searching and sorting, right? That's what I'm going to do this afternoon. What I wanted to do now instead is I wanted to look at another way of doing this, okay? Well, that file I/O was pretty easy because we had a one-liner that read the entire file in, but ultimately all we really cared about was these 2 pieces of data. So what I want to do is, let's make a copy of this thing so that we don't screw up the original. And let's start, Scratch. I'll call it Scratch because I'm going to start manipulating it. Oh, crap. Now it's going to open it. I double-clicked it accidentally, and it's going to open it up in Excel because it's a CSV file. So we're going to have to wait because Microsoft has decided to put in a whole bunch of crap that goes and it verifies that this is a valid Excel, and so it always opens up, takes forever for me to open up. But anyway, let's come back over here, and now that's done. There we go. What I want to do is I want to manipulate this so that I can change all of these things and just directly put them into the map. So whatever my map was called, m.put, I want to put in Bulbasaur and grass. There. I want to change all of those lines to that, okay? But I don't want to type all that stuff, okay? So this is where regular expressions come in. Yeah, go ahead. Oh, thank you. I should have messed with the Scratch one instead. There we go. There. All right. So I could, of course, type it all out. I could go into block selection mode here and type it out so that it's all, plus equal. In fact, that's what we could do here. I don't care about those numbers. I do care about m.put. There we go. But when I get over here to this, I can't do block selection mode anymore because it's not aligned. So that's failed me. Right. What other tool could I bring to bear on this? Regular expressions. Right. I want, and unfortunately it's kind of small, so let's actually go over to regular expression debugger online. I think I've showed this before.
Yes.
Oh, this one sucks?
No, just regular expressions.
What? No, they're awesome. They're really powerful.
Yeah, I think it's.
All right.
I think if I use AI for anything, it's to make those regular expressions.
Okay. All right. Well, fair enough. You could get an AI to probably generate what I'm about to generate here. I want to match that first column, which is 0 through 9, right? But 1 or more. Okay. Or actually, 1 or more. This is going to be 0 or more, right? And this is going to be 1 or more, followed by a comma. And then I want to match the name. So any capital A through capital Z, lowercase a through lowercase z, followed by another comma, right? Except that one or more. Right? And then I want to get that last string there, which is going to be the type there. And again, one or more. Okay? So I've been able to match every single line there. But what I want to do is I want to replace it. First of all, I want it to ignore this thing right here. Then I want to take this thing and surround them with parentheses or with double quotes, put a comma in between, and then put in m.put at the beginning, and then parentheses around it all. The way that you can do that is by grouping them. Right? So if you put parentheses around it, then it will highlight that one token. This will be the second token that I highlight right here. And what you can do is in a regular expression, search and replace, which I'm about to do over here in Eclipse. Find, there we go. I will replace it with m.put, and then I have to escape parentheses. And then I'm going to put in number 1, which is $1, inside of double quotes. And then number 2 inside double quotes. And then finally end the line with a ending parenthesis and then the semicolon there. Do you remember what the map was called, by the way? Pokemon name to type, I think. Okay, we'll just go ahead and replace all of that. Oof. It generated Java code for me, basically, right? Using a regular expression. And what I can do now is I can come over here and forget all about this file IO, right? This thing right here, I'm going to get rid of all of that. I've got the Pokemon to name, and just go ahead and cut and paste that. Pokemon name to type. Right? We've got some problems. What's the problem? Uh-oh. Ah! Far-fetched? Okay. And what else is wrong with you? Okay, so there were, all right, back to the drawing board. Right. Some of those names have parentheses in it. There we go. And also, what was the other one? Something like that. Okay. So let's undo it over here. Undo. And let's try it again. There we go. There's the new one. And then I'll replace it with that one right there. Replace all. What was one of them? Like there was an F or something?
There's a period in space.
Oh, Mr. Mike, come on. Fine. Let's do a period as well. There we go. But was that the only one we can take? It didn't work here. Space. All right. This is not turning out to be as impressive as I hoped. Space. There we go. All right. And no, let's just make sure that where's Mr. Mime? Let's debug it before we use it. I don't see where what number was Mr. Mime? Oh, here, we can look at 29 and 32 there. 29, okay, now it's matched. 32 appears to be matched. And then where was Mr. Mime? Okay, there he goes. There, it looks like he's matched now too. All right, so hopefully that will be the last one. Who knew that Pokemon were so complicated? All right, fine. Replace that with that. Replace all. Okay. Save that just in case we need to. Hey, there, now it all looks clean. All right. Super secret here. This is what compiler design is all about. Finding patterns, transforming those patterns into assembly language or into another language, a transpiler especially. You can do a lot of powerful stuff there. Right? But I was able to do that. I could do the same thing for, what would it be, Pokemon types over here, right? I could surround that with a pair.make, right? But I assume that you would know how to do, actually, let's try. I don't think that there are, so let's get rid of all this stuff. All right, and let's go ahead and move, let's get rid of these special characters that we were making exceptions for there, A through Z, and then I'm going to move this one to the back. So there's A through Z, one or more, A through Z, one or more, separated by a space. There we go. And then finally a space, and then what would it be? 0 through 9, as well as a period, one or more, there we go. Right. And I think that those are all being matched right there. Right.
If you know the length
Oh,
of the file.
yes, because you're going to need that one as well. You're going to need that token as well because we were just ignoring the other one. But yeah, go ahead. What?
If you know the length of the file, it says there's 324 matches.
324? We do know the length of the file over here, 324. Awesome. Yep. So we got all those matched. And then what would you ultimately, oops, I want this one right here. Now there are 3 tokens. Right? You can go ahead and change it to what would you want, whatever the map is, dot put, and then escape the parenthesis there, pair dot make. Oh, you also have to escape the dot, and then another parenthesis there, and then quotation mark number 1, quotation mark number 2, and those are dollar signs number 2, by the way, right? And then you've made that pair, so you want to comma it, and then you want to do number 3, right? And then end that like that. It'll be a number because I didn't surround it with quotes like that. So is that well balanced? Looks like it to me, I think. Yeah. And whatever M was. Now you could just use non-regular expressions here, M dot put to, and let's go ahead and get rid of regular expressions. So what was it before? Pair, Pokemon pair or pair? Pair to multiplier, dot put. Replace all that. There we go. And pair to multiplier, yeah. Okay, so we can get rid of all this stuff now. And I've got no file IO whatsoever. Cool. I just mentioned that because this last week when I had to provide, last week when I had to provide test cases because the output on code post was too long, do you think I went through and typed all that crap? No. I went immediately to a regular expression, took the CSV file and transformed it into C code with one regular expression, and then did it 3 times for each one of those files. All right? So this, I mean, if you get to be a master of this kind of stuff, this is how they make the leaderboards. They just do the, for example, I'm kind of frustrated on it right now because I've now done it 3 different times in 3 different languages, and I'm getting the same answer for all of them on day 3, but they're wrong.
It took me so long.
I get the same answer in 3 different languages and 3 different implementations. But if you're not familiar with it, what it is here is you've got a bunch of corrupted memory here, and you're looking for things that look like multiplication. So mul, M-U-L, and then like that represents a multiplication of 948 with 148, right? But there are invalid things. For example, if you have mul and then it doesn't have a proper closing bracket, and mul with like a star there or whatever. And so what you can do is what I did at first is I did a regular expression, right? And there's the regular expression to grab all of the valid multiplications. And there are 732 of them. I did it in Python. There are 732 of them. I did it in Java. There are 732 of them. But every single time I try it, I come up with the number that agrees across all of these things, but it's wrong for some reason. And I'm really frustrated on day 3 there because I cannot get it. So what did you end up doing?
Like 150 lines of C and regular expressions.
Okay. Regular expressions with C?
Yeah.
Oh, okay. So you brought in library or something to do it?
There's a built-in library.
Okay.
Regex.h.
All right. I don't have it open, but I can show you my solution here since we're done. eventually that'll come up. But basically, I just did a regular expression here, right? And the regular expression is mole, followed by an opening curly bracket, 0 through 9, at least one of them, and then 0 through 9, 0 or more of them, because it says it was 1 to 3. And I even went back and I verified that they were all at most 3 digits. There were no zeros, there were no leading zeros, et cetera, et cetera, et cetera, right? I just pulled that out in Python. When it loads up here.
Did you do it in Python?
Why?
Did you do it in Python?
Yeah, I mean, well, I did it in 3 languages because it kept getting wrong. And so I did it initially in Python. Where's day 3? There we go. All right. And there's my regular expression that went through the entire file, pulled out all of those valid multiplications, iterated over them. This is way more code than it needs to be because, again, why the hell are you wrong? Why the hell are you wrong? I'm checking everything that I could think of. But this other regular expression pulls those 2 numbers out, multiplies them together. I verified that it's not over 199 or 999, that it's not less than 1, right? But I kept getting this value and it kept telling me that it's low. So I went back and I even looked at the ones that were invalid, right? MUL, and I could find, and I did it by hand. I looked at every single one of them and every single one of them was invalid. So I went, that's why I was on that Discord asking for day 3. I think that this is generated uniquely per person. It might not be. And so I was looking for other data, like input and a known correct output, so that I could troubleshoot my own code. Because if my solution works on, say, your input and output, there's something wrong with mine.
Yeah.
And you can't get more than 1 input and 1 output, because it definitely works for the test. But that's the power of regular expressions.
There's also those do's and don'ts in there, and you can like toggle on and off the multiplication. And that's the part 2 of it.
That's I haven't gotten there. I haven't gotten there yet because I can't get past this one. So if anybody has any solutions out there, we do have 3 viewers. So if you're doing Advent of Code day 3, please let me know. It's very, very rare, but like 1 year, several years ago, they did have some bad input and output for some users. So nobody's perfect, right? But I'm racking my brains here because there are 732 of those valid things, and I calculated them correctly, damn it. Right? But you can use regular expressions to do a lot of powerful stuff. That's the takeaway here. All right. Any questions? No? Then a reminder that our final is when? Thursday? All right, so let's look at Canvas here. Come on. Oops. All right, I don't have to do duo thing, hopefully.
Duo sucks.
Here we go, this is the class. So just verify it down at the bottom here. Yep, final exam, that's a full final exam schedule right there. The final exam is Thursday. It will open up. I've not yet set it up yet. So, it redirects to that anyway. It'll open up at 12:01 a.m. It'll go all the way till 11:55 p.m. or 11:59 p.m. So you'll have a 24-hour window minus 2 minutes to do it whenever you want to do it, wherever you want to do it. We're not going to be in this room. Nobody will be here. Take it at home. If your computer fails for whatever reason, get down to the lab. They're open 24/7 with your N-card access. The building is open 24/7 on the south side, the accessible ramp down there. Also, one last thing, make sure that you're doing the PDC post surveys. That is 35 points of your grade, so it's worth more. It's like worth a lab, almost a lab and a hack, but you have until midnight to finish those. All right. Oh, then I'll have a good break and good luck on the rest of your finals too.